Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Gandhinagar. I am the subject matter of Power System 2 subject, which is in the 5th semester Electrical Engineering, and TTU subject code for of this subject is 3150911. Students, currently we are discussing the practicals of this Power System 2 subject, and we have completed all the theory section of Power System 2 subject. And for which we are performing the MATLAB simulation for different parameters of the transmission line. So this is our fourth experiment. Before this we performed the three experiments. The experiment number 1, that we performed the MATLAB programming for the computing the voltage regulation corresponding to the power factor for the short transmission line. Then in experiment number 2, we have checked the performance of the medium transmission line, means voltage regulation corresponding to the power factor for the medium transmission line. And then we have discussed the voltage regulation corresponding to the power factor for the long transmission line. Now in today's presentation, this is our experiment number 4, in which we are going to check the MATLAB programming for the computing the ABCD parameters of short, medium and long transmission that we have already discussed in the theory section. We have derived all the in detail all the parameters of the short, medium and long transmission line, all the ABCD parameters that we have derived. Now let us see how the CD parameters can be computed using MATLAB programming. So for that we need to start the MATLAB, and the program that I have already skipped over here in this theory portion. So I'm just taking a copy of this program, and this is our experiment number 4, and I'm pasting this program over here. So let us see. Okay, so before we feed the data which are asked over here, let's see the programming, means how this parameters can be evaluated. So let us discuss this parameters first. So in this yes, let us start with the program that I have fed in this MATLAB file. So this is the date which is showing that on which day I performed this experiment, and then after the program is being start over here. The main thing that we are finding is ABCD parameters for the short, medium and long transmission line. So yes, percentage compute the ABCD parameters of the short, medium and long transmission line using the value of R, L and C supplied by the user. So here we are going to feed the value of the R, L and C as per our requirement, and for that we are going to find out the ABCD parameters for the given program. So yes, CLC clear all is the command to clear all the things which we previously done in the screen. So let's start with the program. So first is display. It will display the enter your choice. So the choice that we need to feed is, first is for the short transmission line, means insert 1 for the short transmission, 2 for the medium transmission and 3 for the long transmission, for which we need to find out the ABCD parameters of the transmission system. So we need to feed 1, 2 or 3, means whatever we need to find out for particular transmission system in short, medium or long, we need to feed just number, and then after the program will enter automatically into that type of transmission line solution. Now then after it will check input, means enter the choice, and then after we need to enter the R, L, C and F, where R is the resistance in ohms, L is the inductance of the transmission system in Henry, C is the capacitance in farad, and F is the means frequency of the system for which we are finding the ABCD parameters. Now let us start this program. So X is equal to 2 pi FL. So for inductive reactance we are having XL is the 2 pi FL, and this is the formula for the inductive reactance, and the impedance is R plus X into I, and Y is equal to I into 2 pi into FC. So this is the nothing but the 1 upon 2 pi fc. Generally x is equal to, and y is the reciprocal of this, so 2 pi fc will be in the multiplication of the I. So if check is equal to 1, means it will means compare over here. If we feed it the 1, then the data is equal to 1, b data is equal to z, c data is equal to 0, and the d data is equal to 1. So yes, ABCD in Cartesian form, the result A data, B data, C data, and D data, and it will show the result and check if 2, and then it will display the enter 1 for the nominal T method for the medium transmission line. We are having two types. One is nominal T method, and second one is for the nominal pi method. So yes, it will display enter 1 for the nominal T, and second one is for the nominal pi. And as is the input that we are going to feed, that if we go to feed 1, then it will solve for the nominal T, and if we enter the number 2, then it will solve for the nominal pi method. Here as is equal to 1 is fitted, then A data is equal to, these are the equations for the ABCD parameters for nominal T method. So we are just put all the equations over here, where A is the 1 plus y into z divided by 2, where B is the z into 1 plus y plus z divided by 4, and where C is the data y, and D is the 1 plus y into z divided by 2. The result that will display is A data, B data, C data, and D data. Else A data is equal to 1 plus y into z divided by 2, where B data is z, C data is 1 into 1 plus y into z divided by 4, where D data is equal to 1 plus y into z divided by 2, and that will again show the result A data, B data, C data, and D data. And here the program ends for the medium transmission line. And if check 3, if we place 3 over here, then for 3 A data is equal to cos square root y into z, for B square root y by z into sin h square root y into z, and C data is 1 or square root z divided by y into sin h square root y into z, and D data is cos h square root of y into z. And then after result will be displayed for ABCD parameter. So yes, here if and else command is placed, whatever the number which will be fed by us, and whatever the data which will fed by us, according to the data and according to that transmission system, this program will solve the parameters, and it will show the result of ABCD parameters. This is what the program means, that the programming that we fed over here. Now I copied this program over here. Now I have copied this program over here. Now let us go into the first parameter, that over here you can see that we need to feed the number, means for what transmission system we need to find the solution. So let us see. So over here you can see that it is asking for the enter your choice. The number 1 for the short transmission line, number 2 is for the medium transmission line, number 3 is for the long transmission line. So here I am going to feed in the data. So I am putting number 1 because we need to find out the solution for the first, that is the short transmission line. So I am putting a placing 1 over here. Now you can see that check 1 means it is entered in the short transmission line analysis. Now we need to feed the data for the RLC and frequency. So here I am feeding R is equal to 20 ohms. Then after it will ask for the inductance. Inductance is, suppose I am feeding 0.1655 Henry. So yes, and it is means acknowledge the number, means whatever I feed it over here, and C, suppose C is CO, and the frequency supply frequency that I am putting over here, that is 50 Hz. So the result which is shown over here, you can see that 1.000 plus 0.00 I. Then this is the data which we get from for the ABCD parameter. So this is for the A, this is B, this is C, and this is D. So this is A. For A it is 1.000 plus 0.000 I, and this is for A, and B is 20.4 times 0 plus 51.9934 I. Then again the C parameter is 0.000 plus 0.000I plus 1.000 and then plus 0.000I. So this is how we can solve the this is how we can solve the medium transmission system. Now let us feed the program. Let us again feed the program for the medium transmission system. Now again I have copied the program. Now I am pasting over here. This is Control V. Now it is again asking for the enter your choice. Now I am entering my choice over here. The number 2 is for the medium transmission line, so I am putting number 2 over here. So 2 is taken over here, means acknowledged over here. Now it is asking for the values of the RLC, so I am entering for R, that is 20 ohm. Then L is 0.1655. I am entered over here. And asking for the farad, that is capacitance, so it is 1.0027. E small e minus 6. So it is in microfarad, that's right. So it is taken over here. Now enter the frequency, so it is 50 Hz. So I am entering 50 Hz over here. So 50 Hz. So this is the data which is shown by as a part of the two methods for the medium transmission. So here the Y and Z, X, Y and Z that have taken from the feeder data. X is 51.9934, Z is the 21 4 times 0 plus 51.9934I, and Y is the 0.0000E 00 plus 3.1501 e raised to 04I. Now it is asking for enter the 1 for the nominal T method and 2 for the nominal Pi method. So we are going to solve the nominal T method first. So for the nominal T method, we are feeding the nominal Pi method. We are putting the parameter over here. So I am entering to here 2. So the result which is shown over here, you can see that the 0.9918 means this is the parameter A, this is B, this is C, and this is D for this system. So yes, you can see that if I place feeder 2 over here, then this is the value, that is 0.00918 plus 0.0032I, 20.000 plus 51.9934I minus 0.0000 plus 0.003I plus 0.9918 plus 0.0032I. So this is the ABCD parameter for the nominal Pi method, which the data I have inserted for the given system. Now again I have copied the program and I am pasting in the command window. So I am pasting over here. So again it is asking for the choice. Now we are finding for the nominal T method. So enter your choice. So here we are finding for the medium transmission line. So again I am putting 2 over here. Now it is asking for the resistance. So I am putting the value of 20 ohm over here. Now then after it is asking for the inductance. So again I am putting the value of inductance over here, 0.1655, that we have already taken. And then it is asking for the capacitance, which is in the farad. So I am taking 1.0027 E, 1.0027 e raised to minus 6. So it is acknowledged all the data RLC. Now enter the frequency. It is asking for the frequency. I am entering frequency over here. So it is 50 Hz. So now again it is asking for the nominal T or nominal Pi method. So in previous case we have determined for the nominal Pi method. Now we are determining for the nominal T method. So I am putting 1 over here. So it is 1. So this is the value which is showing ABCD parameter of the given system, that is 0.9918 plus 0.0032I. This is the A. Then this is B, 19.8362 plus 51.8120I. This is the B parameter. This is the C parameter, 0.0000 plus 0.003I. And the D parameter is 0.9918 plus 0.0032i. So this is for the second method, that is medium transmission system. Now let us find out the solution for the third method, that is the long transmission system. Again I am pasting the program over here, and then after we will find out the long transmission system. So I am pasting the program over here, and again it is asking for the enter your choice. So I am putting the 3 over here. So now I am entered for the solution for the long transmission system. Now again it is asking for the resistance, so I am filling the value of the resistance over here. You can take any of the value of the R, L, C, and manually you can solve by the equation of the ABCD parameter of the respective transmission system that we have already discussed in the theory section. So you can use that equations to solve it manually. This is the MATLAB based program, so it is showing all the parameters directly. Means computer is calculating all this, but you can compare your answer, or you can check your program whether it is correct or not by calculating this, means by putting this values manually in the equation, and you can calculate by your own way. So this is the value of R. Then after the L is 0.1592 that I am filling over here. So then after it is the farad, so it is 9.54. You can take any of the value. I am taking the random values over here. 5493 e raised to -7. So over here it is I have taken. So all the values of R, L, and C's are acknowledged by the program. Now I am entering the frequency, that is 50 Hz. So this is the result which is shown X, Y, Z. So X, Y, Z of this long transmission system is 50.0142. Then the Z is 32.0000 plus 50.0142i, and Y is the 0.00 e raised to 00 plus 3.000 e raised to -4i. So according to this values X, Y, Z, the parameters, ABCD parameters that I have calculated by this program is the A parameter is 0.9925 plus 0.0048i, and 31.8401 plus 49.9403i, and the C parameter is -0.0000 plus 0.0003i, and the D parameter is 0.9925 plus 0.0048. So this is what the MATLAB programming for the computing for the ABCD parameter for the short and medium and long transmission line. So whatever the data you feed it, try to calculate that example by your own way manually with the help of equations that we have already discussed in the theory section. So this is what I am done for this presentation, and if you have any query or doubt related to this topic, we can solve your topic related queries in our doubt solving session. Or if you have any further query arise after watching this presentation, then feel free to call me to solve your doubts related to this programming. Thank you very much, student. Thank you all. Jai Swaminarayan.